Hello ladies and gentlemen, this is Spellbinder doing a report on the next dust bowl to hit America. That's right, it's been 80 years cycle of the solar activity, and it appears that we're going back into that cycle again, which lasted in the 1930s, just about 10 years from 1930 to 1939. It was a bad time. A lot of people lost their farms and everything blew away. A lot of it was this bad, soil conservation and growing what they do on there, like wheat and what we got now, GMO corn. And it leaves a lot of, when the corn dries out, it leaves a lot of sun hitting the surface, drying the soil out even more than it was before. And it appears this is what's causing the temperature rise in the record temperatures as in the 1930s. We're having the same type of temperature records going across the country. 61% of the country is under one form or another of a drought. And this is the long-range forecast of U.S. drought based on solar activity by Dr. Theodore Lenschedit. I guess. It's hard. I'm not really sure how this is pronounced in German. But it's the Skoter Institute of Research in Cycles of Solar Activity in Germany. And the introduction is almost the basicness of this whole thing. Drought occurs if there is a lack of insufficiency of rain for an extended period, which causes a considerable hydrologic imbalance and consequently water shortages, crop damage, stream flow reduction, and depletion of groundwater and soil moisture. Drought is the most serious physical hazard to agriculture. In the U.S., the Dust Bowl droughts of the 1930s and 50s are the most severe examples of the devastating effects of extended periods of dryness. In the 1930s, drought virtually covered the entire plains for almost a decade. Many crops were damaged by deficient rainfall, high temperatures, high winds, insect infestations, and dust storms. It also spread as far north as in Canada. So I've heard a couple of people from Canada saying it's dry as can be up there also. Well, the Dust Bowl actually extended into the Canadian territories up north. So if you guys are experiencing this, this includes you also, that this all happened in the 1930s and 50s. The resulting agricultural depression contributed to the Great Depression's bank closures, business losses, and increased unemployment. These hardships sent economic and social ripples throughout the country. Millions of people migrated from the drought areas in search of work, which resulted in conflicts between the newcomers and the long-established residents and overburdened relief and health agencies. Understandably, such conditions were a strong motive for monitoring, migrating, and predicting drought indices have been developed, and the National Drought Mitigation Center, NDMC, offers advice in planning for drought. NOAA's Climate Prediction Center and the U.S. Drought Monitors, as well as many other institutions, publish assessments of the current conditions and seasonal outlooks. The immediate cause of drought is the predominant sinking motion of the air that results in compressional warming or high pressure, which inhibits cloud formation and results in less precipitation. Notice I've been looking at the United States map on Intellicast, and last week, especially, and the week before, it was spotty, just little popcorn thunderstorms popping up, except for in Texas, where they got above normal precipitation since they just came out of a drought down there. Prolonged droughts occur when large-scale anomalies in the atmospheric circulation patterns persist for months, seasons, or even longer. The extreme drought that affected the United States and Canada during 1988 was caused by the persistence of a large-scale circulation anomaly. There are many variables that may cause such anomalies. air-sea interaction, soil moisture, land surface processes, topography, internal dynamics, and the accumulated influence of dynamically unstable synoptic weather systems at the global scale. According to the National Drought Mitigation Center 2003, even scientists making use of the general circulation models are no match for this complexity. They do not know how to predict drought a month or more in advance for most locations, especially in the extratropical regions. The current long-range forecasts are very limited reliability in the tropics. Empirical relationships have been found between precipitation and ENSO events, but few such connections have been confirmed above latitude 30 degrees north, which I'm in the 40-degree area. Long solar motion cycle in U.S. drought. So it is a notable step forward that the sun's varying activity offers a means to predict U.S. drought many years before the respected event. I have shown that the ENSO events, the North Atlantic Oscillation, NAO, and the Pacific Decadal Oscillation, PDO, extrema and global temperature anomalies, drought in Africa, and European floods are linked to cycles in the sun's orbital motion around the center of mass of the solar system. And it's back to his report from 1983 to 2003. Figure 1 demonstrates that such relationship also exists between U.S. drought and solar cycles. So don't let the global warmists try to take money from your pocket to put it in theirs over a carbon tax, when you can actually see that in the 1930s, right at the beginning of it, we had the worst drought, so predicted up to 2007. Well, they're showing 2018 not as bad, but we're up to about what is in 1960s actually. We're up about there, I would say. And this is figure 1. The brown curve represents raw monthly values of the Palmer Drought Severity Index. Let me just put this back up here so you can look at it while I read this. The PDSI for 1900 to 2001, the NCDC 2003. This index was devised by Palmer in 1965 to indicate the severity of dry and wet spells over the continuous U.S. It uses monthly temperature and precipitation data and the variable water content, AWC, of the soil, also called soil water holding capacity. It is based on the supply and demand concept of the water balance equation, taking into account more than just the precipitation deficit at specific locations. It is standardized to local climate, so it can be applied to any part of the country to demonstrate relative drought and rainfall conditions. The U.S. Department of Agriculture uses it to determine when a grant emergency drought assistance. Palmer values lag emerging droughts by several months, but respond reliability to weather conditions that have been abnormally dry or wet. These severe months, or the vertical scale in figure 1, indicates the percentage of the U.S. area affected by moderate to extreme drought. In 1934, the PDSI reached a maximum value of 63%. As I said, 61% of the country is under one form or another drought. But yet over in Europe and in England, UK, they're getting flooded out like rats, being drowned. I mean, it's pretty severe. It's just rain, rain, rain. They're getting a week's worth of rain almost daily in the UK. They were reporting from most of the newspapers. Putin had to go down to southern Russia to check on a flooding that happened down there. So, in China is having floods everywhere, but yet we're dry. as a bone. I sometimes think it's weather wars going on, but not exactly positive of that with the solar cycle. Or it could be a combination of weather wars, the solar cycle, and the weather wars being caused by the spraying of chemtrails to block and dry. They may be spraying them to protect the surface from drying out. Who knows? They probably know about this 80-year cycle. It goes on. It's been about 80 years since the 1930s. And therefore, we're having this cycle again coming around of a great dust bowl that happened back in. And it's coming around again. And with all the crops growing out there that, just have enough roots to grow themselves, if they die off, the ground will become so dry that if a windstorm is created and blows across there, well, you have a dust bowl again, or dust storms will start kicking up. The green and blue triangles in Figure 1 mark special phases in the solar motion cycle that can be computed. Such cycles have been used to forecast ENSO events, the North Atlantic Oscillation, NAO, and the Pacific Decadal Oscillation, PDO, extrema, and global temperature anomalies, Africa droughts, and European floods. By now, these forecasts have turned out correct without exception. Strangely, this has not sent any ripples throughout the official science, though it is proclaimed aimed at scientific endeavor to make human life easier for dependable forecasts. The rate of change of the sun's orbital angular momentum L and the rotary force of dl divided by dt driving the sun's orbital motion torque forms a torque cycle with a means length of 16 years. Perturbations in the sinusoidal, I know that word, I just can't pronounce it, course of this cycle recur at quasi-periodical intervals and mark zero phases of the perturbation cycle PC, which means the length of 35.8 years. As to details, I refer to Figure 2 in my online paper, Solar Eruptions Linked to North Atlantic Oscillations. And Figure 1 presents here, zero phases of the PC are marked by green triangles and labeled GPC or TC, greatest perturbations in the torque cycle. Blue triangles labeled LPTC, least perturbations in the torque cycle, mark phases of minimal perturbations. I have shown that these phases indicate the peak of warm PDO region or rings and the coolest phase of cold PDO rings. In Figure 1, they are closely linked to extended dry and wet spells. Obviously, there is a phase reversal in the connection just after the PDSI had reached an exceptionally high value of 63% in 1934. The instability inherited in these conditions seemed to have contributed to the phase reversal, a phenomenon often observed in solar terrestrial cycles. Before the phase reversal, GPTC green triangles coincide with the drought conditions, and the LPTC blue triangles with the wet conditions. In the latter case, this is easier to see in Figure 2 with data subjected to 4-year moving window of the Gaussian kernel smoothing. And here is the Gaussian smoothing in Figure 2, which you can see the triangles, the GPTC, and then you have the phase reversal and the blue triangles up through 2007 when this report, and it actually shows up through 10, but not now. After the drought peak in 1934, the relationship is reversed. Now LPTC's blue triangles consistently go along with the drought peak, and the GPTC's green triangles with wet periods. This pattern has been stable since 1934 and should continue to be stable for many decades, as it is moderated by the cycle of 179 years. So the next extended wet period should begin around 2007 and last about 7 to 8 years, as can be derived from Figure 1. A drought peak indicated by the LPTC blue triangles is to be expected from 2025 on and should last about 5 years. Apparently, this solar cycle is a little bit bigger than they expected, and it came early. The parameters P as predictor of Palmer extrema. Additional indicators of periods of moderate and extreme dryness or wetness are special solar phases marked by red diamonds. And you get up here the red diamonds. Those are what we're going through, and actually shows beyond 2010 a red diamond of the next peak of the cycle 24. Okay, additional indicators of period moderate extreme dryness, wetness, as in the red diamonds. Before 1934, they went along with drought periods. The first phase after 34 showed the same reversal as the other indicators and marked a period of extended wetness. Afterwards, however, the phase indicated by the red diamonds returned to the mode before 1934 after the stabilization one predicted in 1995, while wet condition prevailed, and the next period of drought would begin in 1999. Just this happened, as can be seen in Figure 1 in spring of 98. The Palmer percentage was still at 0. Towards the end of 99, it reached already 14%. In the summer of 2000, the high value of 36% was observed in 2002, nearing 39%. Of the area of the contiguous U.S. was affected by moderate to extreme drought. When the consecutive intervals between GPTCs and LPTCs are nominalized to 1, the phase in question, red diamonds, fall at 0.618 in between. In parameters 0.1 or 618 P of the fundamental importance, as it is a regulator of stability in dynamical systems of all kinds, from atoms and molecules to planetary systems. References on this. P determines the ideal ratio length of the rising and the sinking branch of the 11-year sunspot cycle, but also of longer and shorter cycles of solar activity. Figure 3 presents an example and functions of P in the torque cycle, mentioned above as an indicator of maxima and global temperature anomalies. This being Figure 3. Figure 3, after Predictive and Oort, 1992, shows monthly atmospheric temperature anomalies. Celsius average over the northern top and the southern bottom hemispheric mass between the surface and 25 kilometers height based on radio sound measurements. The anomalies are taken with respect to the 1963 through 1973 means condition. The smooth curves are based on a 15-month Gaussian type filtered values. The filled triangles mark zero phase in the torque cycle, and the open triangles the perimeter P between consecutive zero phases. Obviously, the maxima and the anomalies are consistently correlated with the zero phases in the torque cycle in P, though the intervals between the consecutive zero phases show large variations in length. The match is of satisfying precision. As far as there are deviations, they merely amount to a few months. The last 5 extremas in the temperature anomalies were correctly forecast on this basis. In 2000, the approach of the next P phase between GPTC of 2007 and LPTC at 2025.4 is 2018.4, as indicated in Figure 1. Another Palmer maximum is expected around this date, as the relationship is based on astronomical data that can be computed. The forecast could be extended further into the future, but who would check such predictions? Number 4, background and outlook. The empirical relationship presented here would have a practical value even if there were no theoretical background. Many practices in meteorology are on this heuristic level, yet there are hundreds of observations which show that within a few days after energetic solar eruptions, flares, coronal mass ejections, and eruptive prominences, there are diverse meteorological responses of considerable strength. Then you have all these records. Such eruptions accumulate around critical phases of solar motion cycles so that they can be predicted. A long-range forecast experiment on this basis covering 6 years was checked by astronomers in Space Environment Center, Boulder. It reached a hit rate of more than 90% through solar eruptions occurred at quite irregular intervals. Radiocarbon deviations derived from the analysis of dated tree rings serve as a proxy for the varying intensity of the sun's eruptional activity. Comparison with proxy data for climate show a close co-variation for thousands of years. Beer and Jews and so on. These people did the research and tests. Similar relationships were also established between the variable lengths of the 11-year sunspot cycle, as of course proxy of the intensity and frequency of the solar eruptions and temperatures on Earth. Contrary to the assertions of the IPCC scientists, there are several physical models that could explain the effects of solar eruptions on climate. And here we go with that. So the IPCC is making things up and using in the background solar activities for their means carbon tax. Some of them were published decades ago. So there is hope of a more detailed cause and effect explanation as soon as the still rudimentary theories of solar activity and climate change reach a more mature stage of development. Anyway, the correct forecasts of the U.S. drought beginning in 1999 and a dozen of further successful climate forecasts exclusively based on solar activity show already now that the IPCC's claim that there has only been a negligible solar effect on climate change in recent decades is not tenable. Ironically, just drought and the greatest threat attributed to the alleged man-made global warming has turned out to be regulated by variations in the sun's eruptional activity. There you go. There it is. It has successfully predicted key climate events using the solar activity as the cause of it. Droughts, wet periods, heat, colds. I mean, when this solar cycle 24 is over, it's going to get pretty cool. Literally. These are references. You can check these references out also. They're all there, all for your watching and reading. I mean, you just going to have to do your homework on this and not believe Al Gore and the rest of the company, because they're not going to tell you anything that you need to know. They're out there to make money. And they saw a way of doing it. They actually saw a way of making lots of money. And not telling you where they're getting their forecasts from, but to blame people for it. And environment. And there's a lot of web pages that are political blogs and stuff on here who will back up Gore's ideals and everything. But the solar activity is happening right now, and that's why it is just that bad out there. And you're going to have to wake up to this sooner or later to understand it. This is just a paper. I'll have a link to this down below, and you'll be able to read this for yourself, check the links out, and make your own decision. Is it solar or is it people? I believe it's the first. It's solar. And people have very little to do with a lot of it. I mean, the Dust Bowl was actually created from mismanagement of land. They grew wheat and stuff, and when it got burned off, it just left dead ground there to dry even more under the solar activity, and it created the Dust Bowl. Yeah, I guess you could say people caused the Dust Bowl. But it was the sun's excitement, activity, that dried the soil out to begin with. If it was a wet period during that time, it wouldn't have never happened. But it was a dry period. But they didn't get the forecast to plant trees. They actually planted trees at the end of the 1930s Dust Bowl. They started planting trees to cut the winds off and everything across their plains. That's why you see around fields now, they'll leave a border of trees around their fields. Well, there was a purpose for that, to cut the wind off from running across their fields. And that was the logic behind that, which is still used today. I mean, I can go out here in the Ohio Valley anywhere and see trees around every field and small forests. There's a reason for that. It cuts the wind off in case there is a drought. It won't blow their topsoil away. Until next time, this is Spellbinder saying be good at it, and good day.